Anjali, good evening, beta. Are you getting the links? Good evening, beta. Can you hear me? Am I audible? In the group, you'll post message that class started. Yes, beta, in grade 9. Post the message in the group that class started, beta. So today we will be doing some theorems related to circle chapter. Kanishk, today online, what happened? Now come on children, pay attention and try and understand the questions. The theorems, what I am going to teach is very, very important for you. So please kindly note down tomorrow when you are coming offline. That time I am going to see your notes. So Kanishk, please kindly note down all these things. So I am starting from that theorem, which is very, very important for you, beta. So the first theorem is for today. Good evening, Anushri. Arunisha will not fight with me. Every day you are taking some other name for me. Now come on, beta. Let's start the work, please. So now look here. Two chords AB and AC of a circle are equal. Two chords AB and AC of a circle are equal. So first we are going to draw two chords. Okay. Yes, I know you are going to punch me for that. So now two chords AB and AC of a circle are equal. Come on, get back to work, please, children. Two chords AB and AC of a circle are equal. So first we have drawn one circle. Okay. After drawing the circle, beta, this is one chord, and another chord we are going to draw like this. So here, when you are writing AB and AC. So both the chords are equal. So what they are telling, two chords AB and AC of a circle are equal. We have to prove that the center of the circle lies on the angle bisector of BAC. We have to prove that first what we are going to write, given chord AB and AC of a circle are equal. Okay. Now what they are telling that this chord and this chord is of equal length. If this is 5 centimeter, this will also become 5 centimeter. Understood? So this is what they are telling. These two chords are equal length. One over. Now what they are telling that we need to prove that the angle bisector of BAC. Understood? So what is bisecting? The angle bisector. Note down the angle. Prove that. See what they are saying. Prove that the center of the circle lies on the angle bisector of angle BAC. The circle lies on the angle bisector of BAC. So that's a very, very important thing we need to prove. I hope you might have understood. So here we need to prove this part. So prove that the center of the circle. So we will just write one center here. We will mark it as O. Okay. So center of the circle is coming in the angle bisector of angle BAC. Huh? So BAC. Okay, I am teaching very slow, very slow. What they are telling that this is two chords, and after that, what they are telling the next important point is कि these two. Okay, I'll slow down. Happy? So now these two chords are there, chord AB and chord CD. These two chords are of equal length. These two chords are of equal length. Okay, so if this is 5 centimeter, this is 5 centimeter. Now they are telling that one angle bisector is there. So we will name it as M beta. Okay. So AM is the angle bisector of angle BAC. Angle bisector means the one which bisects the angle into two equal halves. What is the meaning of angle bisector? The angle bisector, hello Avni, the angle bisector bisects the angle into two equal halves. The angle bisector bisects the angle into two equal half beta. So that means AM, if total angle is 100 degree, then this angle will become 50 degree and this angle will become 50 degree. That is the speciality of angle bisector. So AM is the angle bisector. What is AM beta? AM is the angle bisector. What is the meaning of angle bisector? The angle bisector bisects the angle into two equal halves. So AM is the angle bisector. Now what we need to prove that center of the circle must be on this angle bisector. Understood? So you need to prove here that this center of the circle O must lie on AM. What we need to prove? To prove that center of circle. To prove that what beta? Center of circle O lies on AM. This is what we have to prove. Understood? The center of the circle lies on AM, which intersects. So this is exactly the most important part. Hi Himanshu. So this is exactly the most important part, beta. We need to note down. I hope. Good evening, beta. So definitely we need to note down this part. This is the thing to prove that this is given. Okay. So now what we are going to do is construction work we are going to do. So what construction work we are going to do? We will be joining BC. So this C we have taken now. So we are going to join BC. BC is not passing center C. Okay. So we are going to join BC. So note down here what we are going to write: joining BC, construction. In construction section, we will be writing joining BC. So we have joined BC. We have joined BC. इसके बाद का क्लास है बेटा, इसके बाद का क्लास है, जरूर आना, तुम्हारे लिए फिजिक्स का न्यूमेरिकल से आज फिजिक्स पढ़ाने वाली हूँ. Yes beta, construction means joining BC. So we are going to join BC. Once we are joining BC, what is the next work we are going to do? Till here, Aru, understand now? Now we have to draw bisector. What we are going to draw? Bisector. We are going to draw bisectors. We already draw one bisector AM now beta. So we will write drawing bisector AM. Drawing bisector AM of angle BAC. So we can write drawing bisector. Drawing bisector AM of angle BAC. Drawing bisector AM of angle BAC. Understood till here beta? So this was the given section to prove that in construction. In construction only one thing you did beta, you added B and C, and then what you said, you are drawing this line. Okay, now let's take this point as D. The D point is that contact point between BC and AM. What is D? D B is the contact point between AM and BC. Till here it is done beta, because after circle construct here, surface area and volume is there, statistics is 2-3 chapters are only there for syllabus to finish. So we will be focusing, and again we will revise everything. Okay. Now beta, what we need to do? We will take these two triangles beta, BAD and DCAD. These two parts we are going to take. Okay. Now these two triangles we are taking. So in the proof section, what we will do? In proof section, what we are going to do? We will take triangle BAD. So in triangle BAD and triangle CAD. In triangle BAD and triangle CAD. These two triangles we have taken. Now beta, what is already given? Chords are equal. So AB is equal to AC. Here chords are equal. Chords are equal. So AB is equal to AC, chords are equal. Now what we will write beta? BAD, ACD, because AM is the angle bisector now. So if see, this one is equal to this one, already given in the question. So first we wrote this equal to this. Then after that, second point. Second point is, this is the angle bisector. So this half angle will be equal to this half angle. We can write like that, na? This angle is equal to this angle, x will be equal to this angle y, because AM is the angle bisector. So we can write like that. So angle BAD is equal to angle CAD. Why? Because AM is the angle bisector. AM is the angle bisector. AM is the angle bisector. So since AM is the angle bisector, we AD is equal to AD. In both the angle AD common. So what we have seen, we saw this triangle and this triangle, this equal to this angle equal to this angle, and this side is equal to this side. So what is exactly the criteria? Angle side. Okay, Sham, no problem, beta. So now look here, side, angle, side. Okay, side, angle, side. So definitely triangle BAD is congruent to triangle CAD by side, angle, side criteria. So beta, when it is side, angle, side criteria, then one thing we must remember, side, angle, side is coming, that means what beta? That means BD is equal to, now by CPCT. Once congruency is proved, now our second strategy is, by CPCT, we can say that this side, by CPCT we can say this side is equal to this side, this angle is equal to this angle. Correct now? This side is equal to this side and this angle is equal to this angle. We can write like that. So we will write that is BD is equal to DC and angle BDA, BDA is equal to angle CDA by CPCT. These two things are coming by what? CPCT, corresponding part of congruent triangle by CPCT. This is coming by CPCT. Done. So now already we know that BD is equal to CD and this angle is equal to this angle. And what is what? Because BC is actually a chord. So BC, what we have drawn? We have drawn a line now. So it will act as a chord. Correct now? It will act as a chord. B to C we are joining. It will be acting as a chord. So what we will write? Can we take this part out now? Can we take this part out now? This is the major section, the last part of the theorem. Till here everybody understood? Come on, tell. Till here everybody understood or not? Tanisha? Till here everybody understood? Okay, I will teach one more thing. No problem. Till here is it clear? Okay, super. So that means till here my children understood by CPCT I brought this. So now beta, if BC is a chord, okay, and we can take it as a line. So if BC is a chord or take it as a line. So since we will write here, so since BC, we will take it as a chord or a line. We will take it as a chord or a line. Next class tomorrow I'll do it. Don't worry. BC is a chord or a line. So once BC is a chord or a line, beta, then this angle plus this angle will be equal to angle CBA plus angle BDA will be equal to 180 degree linear pair. And take this as equation 1. So 2 times of angle CDA is equal to 180 degree. Angle CDA is equal to 90 degree. We will first here write as a line. Okay? We will first here write as a line. After that what we will do? We will first here write as a line that BC is a line, and then we have got CDA is equal to 90 degree. That means this angle D, this is 90 degree. This is coming, this D part is coming as, O is the center of the circle now. This D part is coming as 90 degree. So if this is coming as 90 degree, then BDA also is coming as 90 degree. So both are coming as 90 degree beta. And we only know that from the center of the circle, whatever line is drawn, it is exactly 90 degree. So this is contradictory because see here, from this is BC and center is here, O. But this is coming 90 degree. This is coming 90 degree means what? This part is coming 90 degree means this is exactly chord and O is the center on the line. Then only it is coming as 90 degree, otherwise it is not possible. So what we will write after getting 90 degree, we will say AD is nothing but is the perpendicular bisector. Is the perpendicular bisector of the chord, perpendicular bisector of the chord, bisector of the chord BC. Perpendicular bisector of whom beta? AD is the perpendicular bisector of the chord, and we know that any line drawn from the center of the circle to the chord bisects the chord. Understood? And since we know that any line perpendicular bisector of chord, we know that perpendicular bisector of chord passes through chord. So the perpendicular bisector of chord always passes through chord. This is one of the most important point beta. The perpendicular bisector of chord passes through the chord. That means AM passes through center O. So final conclusion what? AM passes through center O. AM passes through center O. AM passes through center O. This is our final finding, and this is the most important thing. From where we started with we drew two chords which are equal, then we drew one angle bisector because it was given in the question itself. Now this angle bisector must pass through the center. This they have given us to prove. So what we did, we wrote given section. So to prove that, and the construction section. Now in the proof section, what they are telling, in the proof section, what they are telling that these two are triangles. Okay. In proof section, we said this side is equal to this side. This is common, and this angle is equal to this angle. Why? Because this is perpendicular bisector. After that, we proved these two are congruent. Once these two are congruent, by CPCT, this side is equal to this side, and this angle is equal to this angle. Then sum of these two angles is equal to 180 degree. Then half will become how much beta? 90 degree. If this is 90 degree, then any line joining center to the chord is always 90 degree. That means the line passes through the perpendicular bisector always passes through center. So perpendicular bisector always passes through center means if this is exactly O is the center and AM is having O. O is the center and AM is having O. That means AM passes through the center O. AM passes through the center O. This was the point and we have done this point. Got it? So done. We have done this theorem. Everybody, we must go to next part. Are we ready for it? Very good, Beta. So this is indeed a very important part of circle, and this is indeed a very important theorem for any competitive level. Because for competitive level, they will never be asking you to prove this question. No, they will never ask to prove. But indeed, what they will do is they will be asking this sort of question that angle bisector of two equal chords, angle bisector, are they passing through the center or not? So this is for mathematics, for teachers concept and for everyone. This is the most important part. So now we will be going for the next part. Now you check. This is exactly the second section we are going to solve and see this section very thoroughly. Two chords are there. Okay, super. Very good. Kanish, note down this one, below. Two chords are there. What are the two chords? Again, we will take chord AB and chord AC. Two chords are there. Again, we drew the two chords below. After drawing the two chords, we are going to draw the center of the circle O. Okay. After that, definitely this will become radius. So we will try a little center part, will write till here, so that some angle will be subtended. So like this we have drawn. Okay. So like this we have drawn. Okay, beta. Now look here. So this part, little center I am shifting because it is unable to show that angle subtended. So from this section, I am not satisfied with the drawing. Let me draw it. Okay. Otherwise you will get confused. So I will take a circle with this. This is exactly the chord. This is the center point. Just 1 minute. This is AB and this is BC. Now, beta, OB and OC are radii of the circle. What is given? AB and AC are chords of circle. AB and AC are chords of circle. C with center O and radius R. Okay. After that, OB and OC are radii. Understood. OB and OC are what, beta? OB and OC are radii. Got it? Now we can say that now we have to do what is given. After that, they are telling that and such that the center bisector of angle BAC. So what they are given are such that the center O lies on the bisector of BAC. This time they are telling that O is lying on the bisector of BAC. That means AO bisect angle BAC. What is the next part given? AO bisects angle BAC. AO bisects angle BAC. AO is bisecting what? Angle BAC. So if AO is bisecting angle BAC, that means angle BAO is equal to angle CAO. So definitely angle BAO is equal to angle CAO. Because bisector is there, na? And the bisector bisects the angle into two equal parts. So this angle is equal to this angle given beta. Done. Now what we are supposed to do, because bisector angle already given equal, what they are asking us to prove. To prove that, let's check what they are asking us to prove. Okay, so what they are asking us to prove that AB is equal to AC. That means the chords are of equal length. We can say it is the converse of the theorem what we have just proved. It is what converse of the theorem what we have just proved. So now we are going to go with that. So first we will take triangle OAB. So in the proof section, what we will do? Okay, so first in the proof section, we will go triangle OAB. Which one is triangle OAB, beta? OAB triangle. In this triangle, we know that OA is equal to OB. That is radii. What is OA is equal to OB? Radii. OA is equal to OB. Radii. So if these two are radii, beta, that means this angle is equal to this angle. Then if these two are radius, so look at this and this, OA and B, these two are radius, that means this angle is equal to this angle, 100%. If they are radius, then this angle will be equal to this angle. So that means angle OAB is equal to angle OBA. Why? Angles opposite to equal sides of a triangle are equal. Angles opposite to equal sides of a triangle, equal sides of a triangle, equal sides of a triangle are equal. Angle opposite to equal sides of a triangle are equal. That's the major section we have done. Again, beta, we will take triangle in triangle OAC. Now, beta, this time which triangle we have taken? This triangle we have taken. Now, here also, beta, OA and OC. They both are what? They both are radii. Correct now? They both are radii. Absolutely correct. Beta. So again we will write what we are going to write. OA is equal to OC. So if OA is equal to OC, that means this time beta this angle will be equal to this angle. Why? Because again if this side is equal to this side, so this angle is equal to this angle. Correct now? This already given, we will take it as equation 1. Now this is exactly we have derived, so this will become equation 2. So now OA is equal to OC. So we can say angle OAC is equal to angle OCA. Why? Again same criteria. If sides are equal, if they both are radii, then respective angles will become equal. That is angle opposite to equal sides of a triangle are equal. Concept is this simple. That is if this side is equal to this side, so this angle will be equal to this angle. This is the concept. And the theorem is angles opposite to equal sides of a triangle are equal. Angle opposite to equal sides of a triangle are equal. So now we will take it as equation 3. Now beta, can you notice BAO, CAO? This angle is equal to this angle, correct? Now this angle is equal to this angle came. This angle is equal to this angle came. That means overall, all these angles are same. That means if this is x, this is x, this is x, this is x. Means all angles are of equal length. All angles are of equal length. Understood? All angle will become what beta? Equal length. That's the major breakthrough. That means this angle is equal to this angle and this angle is equal to this angle. So from equation 1, 2 and 3, from equation 1, 2 and 3. One told what? One told this angle is equal to, see I am writing with another color. One told this angle is equal to this angle. Okay, means this angle is equal to this angle in the given section already written. Got it? Then second part what we did? We went that this is radius, so this angle is equal to this angle. Then now next part what we did? We proved this angle, this side is equal to this side, so this angle is equal to this angle. That means this equal to this equal to this, and this equal to this. That means all are equal. All, that is what all are equal. So that means we can say angle BAO equal to angle CAO is equal to angle ABO is equal to angle ACO. All angles equal. Done. CAO, ACO, all angles are equal. Now we are going to take these two triangles. Now here we are going to take these two triangles. Now we will say in triangle, because all these parts we have to. Now we'll write in triangle BAO and triangle CAO. Now beta, first part, this angle is equal to this angle because all angles are equal now. So specifically we can say by this angle is equal to this angle we will take. All are equal, so we can write like that. So angle ABO is equal to angle ABO is equal to angle ACO. Proof earlier. Next, this angle is equal to this angle, already we know. Angle BAO is equal to angle CAO. This is given itself. Next, AO is equal to AO common. So AO is equal to AO common. So that means from angle, side, both triangles will become congruent. So therefore triangle BAO is congruent to triangle CAO by angle, side. Then by CPCT, AB is equal to AC by CPCT proof. This is what we needed to prove. We had to prove that, absolutely correct, Himanshu. We had to prove that these two triangles are what? We had to prove that these two triangles were congruent and chords are equal. This is what we had to prove. That if the two triangles are congruent, the chords are equal. And we got success in proving that the two triangles are congruent and the chords are equal. The two triangles are congruent and the chords are equal. We got success in proving this part that the triangles are equal and the chords are exactly, the triangles are congruent and the chords are equal. Come on, check this Pura. Children, everybody understood what was the strategy we did? We did not did any big work. I am drawing it again and showing you what work we did. So yeah, the strategy was this only now. So for that what we did, we drew one circle, we drew two chords, we took one center point, join this center point. This is BAC. First work what we did, we told this angle is equal to this angle already given. After that, this is radius, this is radius. So this angle will be equal to this angle. That means this equal to this equal to this thing. Then this is radius and this is radius. So this angle is equal to this angle. Now this all equal. That means this angle, this angle, this angle, this angle, all equal. And once all the angles are equal, understood, all angles are equal. Correct only much. All angles are equal. That means this equal to this. Now we proved this triangle and this triangle congruent. How? This angle is equal to this angle and this angle is equal to this and this is coming common. So angle, side, both triangles are coming as congruent. That means by CPCT, this part is equal to this part. That's the thing we have done. I hope everybody understood. So this is one thing we tried to solve and learn. I hope you might have understood this part. Come on children, understood now? Super. So this is one thing, please note down because learning is not that much. Understanding and noting down things is more important. You need to learn down the content and you need to note down because noting here is the most important thing here. You need to note down the things very particularly. Then only will we understand the part so clearly. I hope this thing is done. We will go for the next question. Chalan, are you all ready for the next question, please? So these things are very, very important. If any bisector bisect this angle, means from the center any bisector is drawn between two chord, the chord lengths are equal. This is the final conclusion. Any competitive sections, you need to go with this means you can go with this part. We'll go for the next one, the second one, the theorem. The theorem is also, again, this theorem is important. Extra theorems I am giving to you because circle content will not come in one day, 2 day. It's exactly always important. The circle part, what you are studying, is always a very important section for all of you. You must not leave circle. Just say hi to circle and do circle. Yes, very good, Manju. So now look here. That's it, beta. That's the most important thing. What is the question? If two circles intersect in 2 points. Oh, if two circles are intersecting in 2 points. So let the circle intersect in 2 points. If two circles are there and they are intersecting in 2 points. So that means these two circles are intersecting in 2 points. One center we are taking it as O, another center we are taking it as O dash. Then now we are going to draw one common chord between them. So prove that the line through the center is the perpendicular bisector of common chord. Very good. So we will take AM is the common chord and these are the two center joint. Okay. So this part will become what beta? This part will become radius. This part will become radius. Done. Come on, go for it, please. And first draw it. Once you are drawing means half work is done. So first you draw it. Yes, Tanish. Yes, the class is there. Can you post in the group same timing for break? Your class is there. Breakfast class is there. Your second question paper. Okay. Okay. Yeah. Very good, Vita. So we know one thing now. That's good only. We will do only one word. We will do only one word. We will prove that this triangle and this triangle. Congruency are you going to prove? These two triangles, if we will prove congruent, this work will become over now. See, these two triangles, if we will prove congruent, work will become over. Yes, that's only the one thing. Yeah, that's correct only. Correct only. Hmm. We will roughly prove this one because see, once these two triangles will become congruent, the other part will be equal. So first we will make these two triangles congruent. This big triangle congruent, OBO dash and OAO dash. These two triangle congruent, this once we are proving, yes, that's enough. Is my voice clear now? Check. 1 minute, Peter. 1 minute. Is my voice clear? Yes. So now look here. Already, see, already one time we have exactly given. So two circles we are writing. Circles given. Two circles. C with center O and radius R, and C dash with center O dash and radius R dash. Okay. So two circles with center different, radius different taken. Now to prove that, we need to prove that this is a perpendicular bisector of AB. This is only thing. That is OO dash is perpendicular bisector of AB. This is what we need to prove. We need to prove that OO dash is the perpendicular bisector of AB. This is what we need to prove. Okay. Now, what we have to draw? We have to draw the line segment. What line segment we have to draw? Construction I am doing. I will join this, and this. So, joining. Construction is in your hand. Given to prove that written. Now, construction part we are going to write. In construction section, what you need to write here is, write the construction part. In the construction section, what you will say? Joining OA, OB, O dash A, O dash B. Okay, and we need to join all this to run. Now, in the proof section, what we are going to do? In proof section, first we have to take these two triangles we have taken. This one as R radius and this one as R dash radius. So this is R dash radius and this is R radius. Joining the centers, yes, already we have done better. So now we are going to prove. First we are going to take two triangles. What are the two triangles we are going to take better? We will take OA, O dash. Okay. So now we will take in triangle OA, O dash and triangle OB, O dash. So now beta, this side of the triangle is equal to this side of the triangle. That means OA is equal to OB. That is radii of circle C with center and radius R. Radii of circle C with center and radius R. Then beta O dash A is equal to O dash B. Radii of circle C dash with center O dash and radius R dash. Then OO dash is equal to OO dash common. So that means these two triangles are congruent. Okay. So once you have proved these two triangles are congruent, I hope you might have understood these two triangles are coming as congruent. So we can say that the triangle OAO dash is congruent to triangle OBO dash by side. Is congruent to triangle OAO dash is congruent to triangle OBO dash. Side part is done. So we have done. So by CP we can say that this angle is equal to this angle and this angle is equal to this angle. Done. So by CP what we are going to claim? Angle AOO dash is equal to angle BOO dash, and then angle AO dash O is equal to angle BO dash O by CP, corresponding part of congruent triangle. So that means now this angle is equal to this angle AOO dash BOO dash AO dash O BO dash O. That means this angle is equal to this angle is equal to this angle. Our work over. Now we will take this triangle. Our next target is to take this triangle and this triangle. Okay. So these two triangles we are going to take. So now we will take in triangle AOM, and triangle BOF. Now beta, already OA is equal to OB radii. And now beta, we have proved this angle is equal to this angle, that is angle AOM is equal to angle BOM. Proof earlier. This we have proved. And OM is equal to OM common. That means what our target was, we are going to prove that, we are going to show that this angle is equal to this angle by CPCP. Okay, so we are going to write angle AMO is equal to angle BMO by CPCP. Sorry, these two triangles was congruent to the right. Triangle AOM is congruent to triangle BOM by side angle side, and then by CPCP we will say angle AMO is equal to angle BMO by CPCP. Now beta, this is actually a line. This is actually a line. AB is a chord. So since AB is a chord, then beta this angle plus this angle will be equal to 180 degree. Angle AMO plus angle BMO is equal to 180 degree linear pair. But beta, just now we proved this as equation 1. So 2 times of angle AMO is equal to 180 degree. So definitely angle AMO is equal to 90 degree. Proof number. This is what they told. They told that the perpendicular bisector, this and this equal already, now this is coming as 90 degree. So 100% we proved that OO dash is perpendicular bisector of AB. Because AMO is coming 90 degree now. So this part is perpendicular bisector. So we can only say that OO dash is perpendicular bisector of AB. This is the last part. So what was our strategy and how we have proved linear pair? Absolutely correct. And thank you so much because you people are putting effort in understanding the content. That's a very important thing. These theorems are not so simple theorems, but yet these theorems are very, very important. Yes, very good. So OBOO is the common chord. Yes. AB is the perpendicular, the line through which the center. Yes, that's what. And for that, we first did what? Our concept was this only, Aru. So for that, what we did, our strategy was two circle we have drawn, and then this center was O, this center was O dash. We joined, sorry, this circle was O and this center was O dash. And after that, because this point we have taken common point AB, we have taken this one, and then this as intersected at M, we joined this one, O dash, and we joined this one. First concept what we did, we proved this congruent to this by CPCP, and once we did, this angle is equal to this angle, come let us sit without. Go and sit. So this angle is equal to this angle, and this angle is equal to this angle. After that, we do only this one, this triangle and this triangle. Because now this equal to this already we proved. Now this angle, this triangle and this triangle we needed. This is radius, this is already proved earlier, and this is common. So this side is equal to this angle is equal to this. Now this is a line, so this and this equal to 180 degree, half is coming as 90 degree. So we proved that OO dash is the angle bisector, perpendicular bisector of AB. So this was the proof what we have done. So this is again one of the most important things. I hope you might have understood this one better. So these two things we have proved with so much content. I hope you have understood this one. So now we are going to understand the next theorem. The next part of the theorem, the next section we are going to understand. So this part also we have done. Now we are going to solve a problem. So what is actually given in the problem? Okay. So now let's see this one. What is given in the problem? The question we are going to solve. So major one section circle major theorems we have done. Why I am saying this? Because every time everybody came to them. Okay. So now yes, why I am telling. Yes, your correct content is right. In the given figure, so one figure is given. Okay, we will try to understand this question. Don't know which question I have given. So now we are going to see in the given figure is given on the figure. O is the center of the circle with radius 5 centimeter. O is the center of the circle with radius 5 centimeter. OP is perpendicular to AB. So that means AB is the chord of the circle and OP is perpendicular. Then after that what they are telling? After that they are telling that AB, OQ is perpendicular to CD. AB is 6 centimeter, CD is 8 centimeter. That means CD will be here. Okay, CD will be here and Q will be here. This will also become perpendicular. AB is parallel to CD. Okay, determine PQ. So we have to find PQ. Understood? Wait, I'll draw it nicely. Just roughly I was drawing. This is the circle. So first AB given. This is the center of the circle and this is CD. This is P and this is Q. Now what they are telling that O is the center of the circle, radius is given as 5 centimeter. This is 5 centimeter. This will also be 5 centimeter. After that CD total length is coming as what? CD total length is given as 8 and this AB length is coming as 6. So we will say that this is perpendicular, this is perpendicular. So first we will take this triangle. So we know that since AB is parallel to CD and AB and CD are chords of length 6 centimeter and 8 centimeter respectively. Okay, respectively. And one thing is also given now, that is radius. OC is equal to OA is equal to 5 centimeter radius. Now beta, we know that since we know that any line drawn from the center of the circle to the chord is perpendicular to the chord and bisects the chord. So once we are writing like this, that means CQ is equal to 4 centimeter. This one will come as 4 centimeter and this one will come as 3 centimeter. Because total length is 6, so this one will become 4. So we will be able to find by Pythagoras theorem. So using Pythagoras theorem, so in triangle APO, right angled at P. So 100% what we will use Pythagoras theorem means this is exactly coming as 5, this is 3. So this is 5 radii. So we have to find OP is equal to OA square minus, I am taking like a little bit length and go. OA square minus AB square. So this is coming as 25 minus, this is coming as 25 minus 9. So root under 60, that is 4 centimeter. So this total length is coming as how much? 4 centimeter. So OP is coming as 4 centimeter. Now in triangle OQC, right angled at Q. So now OQ will be equal to root under 25 square minus 4 square. So definitely it is coming as 25 minus 60. So it is coming root under 9 is 3 centimeter. We have to find PQ distance. So OP minus OQ is equal to PQ. That is 4 centimeter minus 3 centimeter equal to 1 centimeter. So distance between PQ is coming as 1 centimeter. When down. Yes. So definitely this much part we have finished. So it is coming as 1 centimeter. Determine PQ. So PQ is coming as 1 centimeter. We are going to keep it till here. I am having another class with us. Now physics I am going to teach. Biology, yes. Tomorrow morning I'll teach biology heredity. I'm starting because environment chapter is mostly over now. So little part only left. So in environment half section I will teach tomorrow, and remaining half biology I'll start heredity and evolution. That part I have to teach. That content tomorrow morning I'm going to finish, and then heredity and evolution because test you are writing now. How was the test question? Simple na right now. It will go difficult. Okay. Bye everyone.